We have a relative motion problem here. So we have car number 1 moving at a speed v1 equals 20 meters per second in the direction theta 1 equals 33 degrees north of east. Starts at a point a distance d equals 130 meters due north of a second car number 2. That moves with a speed of v2 equals 30 meters per second and direction theta 2 north of east. Determine what theta 2 is and the time of the collision if if car number 2 is to collide with car number 1. So it's good to draw out a diagram of what the problem is talking about. So here we have two cars, car number 1 and car number 2, as these rectangles here. You can see that car number 1 is going 20 meters per second, 33 degrees north of east. So if east is straight to the right, north is going upward. So this angle is going north of east. Then we've got car number 2 at another angle, theta 2. We don't know what that is. We're going to solve for it. And then v2 equals 30 meters per second in that direction. So if we look at the fact that both cars are moving at the same speed for the whole duration, not the same speed between the two of them, but their speed doesn't change over time, we can use the final position is equal to your initial position plus v delta t. And because they're at an angle, it's good to break it up into x and y components. So our x component is going to be v cos theta, and then our y component is going to be v sine theta. And now that we have our formulas, we can actually look at how the initial positions are relative to each car. So because car number 1 is said to be due north of car number 2, their x coordinate for their position is the same. So x1 initial equals x2 initial. So we're just going to call it the same thing, x sub I. So initial x component. Their y components, however, differ. And from the problem, it says that car number 1 is 130 meters north of car number 2. So we're going to have y1 initial is equal to that distance d plus y2 initial. And the problem is asking what the angle theta 2 is and what the time of the collision is if they are to collide with each other in their paths, which means that their ending position has to be the same. If they're colliding, they're ending up at the same point. So we have y1 final is equal to y2 final, x1 final equals x2 final. So we're just going to use y final and x final for both of these. And then the next step after this is to set up your final position coordinates in terms of your function for position. So we have y final for car number 1 is d plus y2 initial because it's north of car number 2 plus v1 cosine of theta 1 delta t. Then you do y final in terms of the second car, and so it's y2 initial plus v2 sine theta of 2. Oh, I messed up. This cosine should be a sine. My mistake. Let me fix that really quick. Cosine should be a sine. There we go. So sine theta 1, then sine theta 2 for car number 2, and then our x final coordinate should be x initial plus v1 cosine theta 1, and then for car number 2, x initial plus v2 cosine theta 2. So these are your starting equations. Now you can set this y final equation equal to this y final equation, and then same for the x final equations. You can set them equal to each other. And then to find theta 2, you solve for theta 2. And then for delta t, you just solve for delta t. And so each of those is going to require a different substitution based on whichever one you're doing first. But this should be enough for you to work with and for you to start the problem. Let me know in the comments if you get stuck at a certain point. I can push in the right direction. Good luck.